Hi, what's that?
Hi, I'm Kenneth Segata.
Madam Gutierrez.
Cipriano Rivera.
Projectile motion is a form of motion in which an object or particle, called a projectile, is thrown near the Earth's surface as it moves along a curved path under the action of gravity and gravity alone. The implication here is that the air resistance is negligible, which means you don't really have to account for it because it's so small, it doesn't affect the outcome too much. The only force of significance that acts on the object is gravity, which pulls everything in a downward direction. It's not exactly north or south, it's towards the center. So gravity pulls everything in, so from our perspective, it looks like it's coming down. So gravity is a downward acting force that causes acceleration. Because of an object's inertia or resistance to movement, no external horizontal force is needed to maintain the horizontal velocity of the object. Somebody watch a skateboard. All right.
Hello. Now I'm going to be presenting the data and the calculations that we made on the effects of the projectile. And this portion we have our data for our trial runs. We did 3 trial runs and recorded the range and times of each run. After we were finished,
Hello guys, here we have a catapult right here, which is made out of wood. Here we made the arm that's cardboard, for that way it will be lighter, for that way when we send the ping pong ball, it will go farther. And here we added 3 rubber bands, for that way we could add tension, for we could have a greater force, for that way the ping pong ball could go farther. And here we have string, for that way we could stop the arm at a 40-degree angle, for that way when the ball launches, it will launch at a 40-degree, for it will go in a higher point. And basically, it works like this. Thank you.
Guys, where do you put these cables? Why is there only 3?
Oh, there's some attached. Don't worry. Where do we leave ours? You put it back in?
So my bags are here. That's not supposed to be here.
164.
We'll just try it one more time. Just to get it in camera.
Yeah, where are the cables?
This is better. Damn, that's nice.
That's good.
Like that one?
I'm proud of you guys.
Of course it's good. We
How
made
do,
it.
how do you get more attention to it? No, you just hold on to here and pull it all the way down.
We don't have to pull it all the way down either.
Right there?
Break it
Yeah.
one. Sabotage.
All right, who's got the lighter fluid?
What for?
Light that ball on fire, bruh.
Trebuchet for reason.
You're gonna do like,
Yeah, you gotta turn it.
like move your hand like that. Like aim that way. This way?
Angle it.
Yeah.
Wind resistance.
Did you guys try it all the way down here? Mm-hmm. What happened? It went far.
We're still recording, by the way, guys. I don't know.
I think that's hole is a little too small for the tennis ball.
Hey, now.
Ours could
So we're good. You got the one that hit over there, right? Cool. Now we just have to record the time. We gotta figure out the time.
You know, back in the day,
All right, I'm gonna stop the video.
there was competition in the science community.
in continuation with our projectile motion project, we are going to be presenting our data and the equations that we'll be solving for the velocities and height. This is our launch data for our 3 trials. In each trial, we have the range and times that we did for each one. And at the end, we took all 3 trials and got their average values that we'll be plugging into our equations. The first equation is involving solving for velocity in the x-axis. This is our constant acceleration equation we'll be using for the x-axis. And this next portion, we cancel out the initial range because we started from one point which is 0, and then we got our ranges at the end. Then we rearrange our equations, ended up with the distance over time to find our velocity, We plugged in our average values and got the velocity in the x-axis as 3.555 meters per second. Next, we're going to be solving for velocity and the y-axis. Our constant acceleration equation for the y-axis is this one. Then we rearranged our equations, ended up with doing the acceleration from gravity, the negative value, times the average time. Ended up with velocity in the y-axis at 5.748 meters per second. And next is solving for the velocity final for the actual projectile. We took the values that we found in both the x and y-axis, did our Pythagorean theorem. We squared each one, then square root after we added them, and found the overall velocity at 6.758 meters per second. Now for height, we use equations for potential energy and kinetic energy. We set them both equal to 0, cancel out the masses, and both sides have the same term. Then solve for the height by moving the gravity value to the other side. Solve for the values. We plugged in the velocity, overall velocity that we calculated previously over the gravity, and ended up with a height 2.33 meters for the projectile. And that's it. Thank you.